Hello. We continue to talk about energy today, and today we will consider one of the most important laws of nature, which is called the law of conservation and transformation of energy. What does this law say? Everything happens in the world due to the fact that energy can pass from one form to another in the process of occurrence of some phenomena. In life, you can observe different phenomena from the point of view of nature. That is, it can be biological phenomena, it can be mechanical phenomena from the point of view of physics, which can be described, it can be considered in a chemical context. There are a lot of processes that you observe around you. All of them will be described by certain laws. And here is one of these laws, the law of conservation of energy, which we will consider today. So what is this law? We can talk about different examples, but I will give the simplest one. When a body falls from a certain height to the ground, and using the example of this phenomenon, we will look at how energy is converted from one form to another, and why energy in this case will be preserved. So, the situation is as follows. We have a certain object, which at the initial moment of time is at some height, h. So, let's say it has no initial velocity at the initial moment in time, and starts falling with a constant acceleration, which we know is g. In this situation, we neglect air resistance. That is, we say that only the gravitational force of the Earth will act on the body, and under the action of this gravitational force, the body will acquire speed, accelerating to some finite speed just before hitting the ground. This velocity, of course, will not be zero. And here is our task to understand what happened in this case with energy. If we consider the first point from where the fall started, we can say that at this point in time, the potential energy of this body at the initial moment of time was equal to m by g by h, because the body was at a height h and has therefore mass and is attracted to the ground. All conditions for this are fulfilled. The kinetic energy for this moment of time is zero because the body is stationary. What happens now at the end point? Here, if we pay attention to this situation, the situation is reversed. The potential energy, the end point, is zero because the body has arrived at the ground at the starting point where we start counting altitude. But the kinetic energy for a given moment in time will already have some value because now the terminal velocity is not zero. And so the energy is not zero either. What do we see in this situation? We see that the potential energy during this fall has decreased from its value mgh to zero. Kinetic energy, on the contrary, increased from zero to mv squared in half. In this case, we can see with you that there was a transition of energy from one form to another, i.e., potential energy changed into kinetic energy, and we can say that the total energy of this object, that is the sum of all kinds of energy at each point, it will remain constant if there is no external influence on the body. For example, such an external influence here could be air resistance. That is, in the process of such a fall, part of the energy of this body would be spent on overcoming this resistance. But we will now consider a closed system. That is, this is an idealized case when we neglect this resistance, and then energy will be stored in such a system. And so for this law, we can write down that the sum of the two kinds of energy at any moment in time is a constant value, and the final energy for a given moment in time is the sum of the two energies. Thus it turns out that this law will work both for mechanical types of energy and for other types of energy. A little later we will meet with different situations which will be met in other sections of physics, and there we will see how this law is applied to other types of energy. We can consider another such case on the example of using potential energy of a deformed body when we have a reserve of energy, for example, in a compressed spring. Spring to which, let's say, a ball is attached. That is, in this case, we have a certain deformation x, and accordingly, we have a certain potential energy at the initial time, which, as we know, is determined by the formula, x squared in half. The kinetic energy at that point in time is 0. What will happen when the spring is fully open and pushes the ball at some velocity? Here too there will be a transition from strain energy to motion energy. So here we have the kinetic energy of this body is 0. And here accordingly kinetic energy appears due to the acceleration of this ball. And thus we can say that all potential energy which was accumulated in this spring was transferred into kinetic energy of motion after the spring was straightened. In such cases, it is very convenient to investigate this law and use it in the description of various types of motion, because it does not always turn out to be convenient to describe the motion itself, because it is not always simple in its description in terms of the laws of kinematics or dynamics. But when we talk about the law of conservation of energy, it allows us to very quickly connect different points of the trajectory of a given body and solve serious problems quite easily. We can also consider the example of a mathematical pendulum when some body suspended on a thread oscillates around the equilibrium position. Oh, and in the process of these oscillations, there will also be a transition of energy from one form to another. But we see with you that in this situation, the trajectory of motion turns out to be the arc of a circle. In this case, the motion turns out to be not even uniform but unequal accelerated, i.e. it is a motion with variable acceleration. Describing this motion is not the easiest physics and math, but if you and I look at it from the point of view of energy, you and I can easily see that here too, there is a transition of energy from potential energy to kinetic energy. And we can connect different points of the trajectory of this ball and solve problems in which we can use this law. As for these two types of energy, you and I understand that these are mechanical types of energy. And of course, this law for this section of physics can be called the law of conservation and transformation of mechanical energy. A little later, we will connect other types of energy to such phenomena and see that mechanical energy can also be converted into thermal energy, electrical energy, or light energy. There are a lot of phenomena that can show us these processes. So, this concludes our lesson with you. See you at the practice session. Goodbye.